Good morning and welcome to another thrilling day of Discrete Math. Today we are going to be looking at our fifth method of apportionment. So far we've worked through Hamilton's method, Lowndes' method, Jefferson's method, and Webster's method. Today we have what's called the Hill-Huntington method. The Hill-Huntington method is statistically the best. What it does is it tries to minimize any discrepancies when we're rounding. There's a numerical reasons why we use this. This is actually the method that's used in today's House of Representatives. So when we talk about the 435 representatives in the House of Representatives, it comes down to everything is decided based upon state populations and this Hill-Huntington method. So we're going to go through the mechanics behind it. We're going to set up a spreadsheet. All we've got going on for today is to set up the spreadsheet and make it work following through an example. So I'm going to switch over to that. At this point, we're going to walk through, go through the definition, the notes, and the example. I'm going to start off working with the calculator, but after that, we're going to quickly switch over to the spreadsheet because there's a lot of calculations, repeat calculations that go on here, and if we weren't using the spreadsheet, it would take a while, and that's not what the point of this is. So I'm going to switch over now. There we go. That's half on, half off. There's our calculator. So the Hill-Huntington method, we go through the steps just like before. We determine the total population going through, find the natural divisor, natural quotas for each state. We're now going to round, whereas Jefferson is a divisor method. Jefferson rounds down every single time, whereas Webster, a second divisor method, Webster rounds at 0.5. Hill-Huntington rounds according to the geometric mean of the possible values of seats a state could receive. Now I've got a square root of n times n plus 1. Go through this in a moment when we see an exact example. We're going to take the square root of the natural quota rounded up multiplied by the natural quota rounded down, or the modified quota rounded up multiplied by the modified quota rounded down. Because of this, we're going to put this into the spreadsheet and use this as a way of helping us to decide how we make this allocation. And then, because this is a divisor method, we're going to go through just like with Jefferson and Webster. We pick a new divisor, we find the modified quotas, and we follow this rule. And we do that repeatedly until we get the allocation that we desire. So I'm going to go back up top to our example and then go through the calculator trying these out. So this is what you have here. I'll move my table a minute. You can't see that, but I'm moving my table to take a break. Over on the left, we've got our populations. I've got those already entered into the calculator. First thing we do is find our total population in the calculator. I'm going to go through and do that. So total population of 145.3. We find our natural divisor. Natural divisor is the total population divided by the house size. Reading through the example, our house size is 74. So I'm going to divide our total population by 74. We get a natural divisor of 1.96. In the calculator, we did the calculations. We found the natural quotas for each of these before. Now we're going to go into the spreadsheet to work through this. I want to see the Hill-Huntington rounding cutoff figured out so that we can see where that comes from and really appreciate the spreadsheets that we have. I'm going to keep screwing this one up. Divided by 1.96. So this will get us our natural quotas. Put those into our spot. 16.58, 10.46, 9.80, 9.64, 8.52. I am rounding each of those over on the right side in the calculator to the nearest hundredth. Those are our natural quotas set up. Now here, our rounding cutoff. With Jefferson, we would take 16.58 and just round it down. With Webster, we would take that and round up because it's above 0.5. 10.46, under Jefferson, we would round down because Jefferson we always round down, and Webster we would round down for this as well because it is less than 0.5. 9.8 would go down for Jefferson, up for Webster. 9.64 would go down for Jefferson, up for Webster, and so forth. The Hill-Huntington method, our most recent, this one, what we're going to do is something, it's a different rounding cutoff. Rather than cutting off at 0.5 like Webster, we're going to go by the geometric mean. The geometric mean here is the square root of the possible number of seats a state could receive. That being said, up for Tokyo, 16.58, what we're going to do is the square root of that number rounded down multiplied by that number rounded up. So I'm going to put in here, we could have the square root, come on, 16.58 rounded down is 16 multiplied by 16.58 rounded up. So now I have to go back to the calculator. I'm going to do the square root of 16 times 17. That gets us 16.49. So our rounding cutoff is 16.49. The allocation we compare to the rounding cutoff. 16.58 is greater than 16.49. We go up to 17. 10.46. Well, 10.46 could round down to 10 or it could round up to 11. So we're going to take the square root of 10 times 11. Square root of 10 times 11, we go to the calculator, there's a square root of 10 times 11, 10.488. We compare the natural quota, or the quota, 10.46 to 10.48, that is less than this rounding cutoff. We're going down to 10. We will do that for each of the individual natural quotas. So we're going to be repeating this, and it takes a bit of time if you're doing this by hand in the calculator. Each time that we find a new divisor, we'd be going through and doing a calculation again. But we calculate the rounding cutoff. It's the square root of the quota rounded down multiplied by the quota rounded up. We find a new divisor and things that we need to note. If the quota is greater than the rounding cutoff, we round up. If the quota is less than the rounding cutoff, we round down. So we've got a spreadsheet that works through this. Try it out, follow along, get that spreadsheet into and program that in there. There's a few different commands and formulas that we're going to be using in the spreadsheet, so pay attention to those, work through that. My numbers that are used, I'm going to use this example in the spreadsheet. They're a little bit different. They have longer decimals. I just truncated or actually rounded for this example rather than have all the decimals. Try it out, see where we go from there. I'll pick it up again tomorrow.